In this video, we are working on the entire Eastern Cape Math Grade 12 2022 September prelim paper 1. So obviously, we know that this one is going to be quick and straight to the point. Question number 1, we know that these are always usually warm-up questions. There's really absolutely no reason to get these wrong. So anyways, here we can easily work out our values of x by factorizing. Factors of 21, that gives us a 4, it's 7 and 3. To get a positive 4, we know the big number has to have a positive value and the small one has to have a negative. So we're going to get here x go to negative 7 or x is equal to positive 3. The next question, we can see that it's asking us to get an answer here correct to decimal places. So normally whenever we need to get an answer correct to decimal places, it mainly means that we need to eventually use the quadratic formula. So here it would be wrong for you to say x is equal to 3 or x is equal to, or for you to say, or the second portion here is equal to 3. The reason why this is wrong is because we are only able to do that if whatever is on the other side is equal to 0. The reason for that is only if you're multiplying two things together, potentially either one of them could possibly be a 0, because 0 times anything is 0. But then with a 3, you cannot say that potentially either one of them is a 3 for you to multiply them to get a 3. That doesn't make any sense. So here you have to take you can multiply inside, right? And then you can take the 3 over to the other side. And then you can just work this out using your quadratic formula. So yeah, the quadratic formula is something that you can always write out if you're going to use it. And then in terms of putting values into the formula and also putting those values into your calculator, that's where, yeah, you obviously need to be a bit careful, because if you don't do that, then yeah, sometimes it's just a bit messy. But anyways, let's see. So from here, we need to do the following. Let's see what else we need. So from here, we get our two values of x side from the calculator. So the two values of x that we are getting from the calculator, let's see here, we're going to get here. So we're getting here in the calculator negative 0.39. The other one is positive 3.89. Okay, so let's keep it moving. So what you call inequalities. So obviously, if you're going to work out inequalities, you have to firstly be conscious of the specific quadratic equation you're dealing with. So in this case, you also do want to take everything to the left. So before that, let's see, x times 2x is 2x squared. This times the 1 is 2x. 3 times x is 3x. 3 times 1 is 3. The 6 goes over. And then what you have now is like terms, right? 2 plus 3 is 5. 3 minus 6 is minus 3. So the big idea now is that this, we can now see, okay, fine, we're dealing with a smiling parabola. This smiling parabola, they're asking us where it's below 0. And we know it's below 0 here. You see, this is the part where the y values are below 0. You see, starting here from this x value to this x value. So this is where we need to find out what those two particular x values are, because we need this x value and we need this one, so that we can say the graph is below 0 starting from this x value ending at this other x value. So on my side, I don't even usually bother myself. I just use the quadratic formula. See, minus b plus minus b squared minus 4ac, the whole thing over 2a. So this b is a 5, right? Then you're going to have your 5 squared minus 4a. C value is a 2. No, a value is a 2, c value is a negative 3. So all this, let's see what's the next thing here. So all this in the calculator, let's see what we get. Okay, so we're getting x is equal to -3. The other one, x is equal to 1/2. So obviously the -3 is the one that starts first. So we're gonna put a -3 over here, positive 1/2 there. So you can clearly see the x values have to be bigger than -3, and they also have to be smaller than 1/2. So here we can say x is bigger than -3, or x is smaller than 1/2. Let us move on. Okay, so we have something. Okay, this is not very special if you have gone through the algebra course on our website. So the algebra course on our website, I mean, like, it's basically a question 1 hack type of course, because it basically goes through how to tackle all sorts of question 1, paper 1 questions. So here the easiest thing you can do is, anytime you see a square root, find a way you can eventually square what you're dealing with. So the one way to do it is you can take the x over, right, to the other side, because once you've done that, fortunately, to get rid of the square root, what you can do is you can square this side, and then you can also square the other side. So remember, when you're squaring two things that are being multiplied together, like the 2 here and the square root of x, what you do is the 2 gets squared, which is a 4. This also gets squared, so the square root cancels out. Here, 3 times 3 is 9, the -2x, and then plus x squared. So you might as well take everything to one side so that we can just use the quadratic formula. -2 minus a 4 is going to give you a -6. And then fortunately, this one is not crazy to factorize. I mean, it looks as though factors of 9 that can give us a 6 is like just 3 and 3. So get a -1, -6, have to say -3 minus 3. So all this being said, what we can safely say is that x is going to be equal to 3, or x is equal to 3. That's kind of awkward, but then I mean, like, it's just one answer that is identical, so you don't necessarily have to write. But wait, no, this doesn't look right. Nah, I made a mistake here. Let's see. Wait, no, did I? Let me see here. Negative. Oh yeah. Why am I putting a -2? Come on. You see, this is what happens when you do mental math. End up making dumb mistakes. So you see, 3 times 3 is a 9, and then it's like -3 and -3. That's gonna give you -6. Wait, what did I do wrong? Because the 3 and the 3 don't make sense, because it doesn't balance out the equation. Oh yeah, there we go. The -6 was the issue. So let me might as well just, in the next step here, -6 minus 4 would have given us a -10, and then plus 9. Factors of 9 that give a 10 is just 9 and 1. So 9 and 1 are our factors. So let's see here. 9, 1, x. To get a -10, you have to say -9 minus 1. So here x is 9, or x is 1, right? So let's carry on. So carrying on, what do we know? Well, before carrying on, you have to always be careful when you're dealing with surds, because not all answers work out. You see, so you have to test them. So let's try 9. 9, square root of 9 is like 3. So 2 times 3 is 6. 6 plus a 9 is definitely not a 3, so the 9 doesn't work. The 1, square root of 1 is 1. 1 times 2 is 2. 2 plus 1 is 3. Yeah, so the 1 balances out. 1.2, 1.2. Say solve simultaneously for x and y, right? Yeah, so these questions, I mean, like, they are not, I mean, they're just normal, to say the least. So here it looks like you may want to isolate x. This is going to be -2y minus 3. So that is what you want to throw in this equation over there. Doing that, you're going to have here -2y minus 3, right? You square it, and then you have y squared, right? Plus 2 negative 2y minus 3 y again equal to 1. So with all this being done, right, if you're going to multiply out this bracket, two brackets, right, that look identical, you're going to have 4y squared and then plus 12y and then plus 9. So moving on, plus y squared, moving in, multiplying in, so the 2 here and the y, you can put them together, right? So it's going to be 2y multiplied by this, it's going to give you negative 4y squared, and then 2y times the negative 3 and give us negative 6y. The one here can move over, it's going to be minus 1 equal to 0. So okay, so from here we can see that the y squared is left on its own there, so we can just have that in front. 12y here, and then 9 minus 1 is like what? Positive 8. 12 though. Wait, is it? Oh, there's like term here. Yes, this is gonna be 6. Okay, so everything looks fine. Factors of 8 are given. 6 is like 2 and 4. 2 and 4 plus and plus. This is like equal to 0. X minus 4 is equal to x is equal to negative 4. And the other one, what about the other one? Other one is x is equal to negative 2. See, so since you have your x's, right? Wait, but it doesn't look right. Why does not look right? It just doesn't, bro. Like, cause negative plus, yeah, I mean, like, it does look fine. I mean, does it? 4 and 2, yeah, 4 and 2. Oh, that's for y. Yeah, I was getting confused here because I'm thinking, where did the x's come from now? And we cannot make that mistake since there is a variable named x already. Yeah, so there we go. Yeah, that's fine. So the x values, we can just use the small basic equation which we have, which is like what there yeah, no, this equation. So this is our equation of one of our, well, this is one of our equations, right? So we're gonna just throw y in this. It's like x negative 2, the y value is like negative 4, and then here x is equal to negative 2, y value is like negative 4, minus 3 minus 3. This is like negative 8 minus 3 is like what? Yo, yeah, negative 8 minus 3. So it's like minus 2. Yeah, never mind. Whichever way, what am I saying? Am I really about to like do mental math to this? Oh yeah, what I was saying, negative 2 times negative 4, that's like 8. 8 times negative 3, that's already 24. Negative 24. And here, oh, why did I put an equal to sign? I meant minus. So, oh, what about negative 2, negative 4. So, negative what? What is the other one? So, negative 24 minus 2 is what we have. So this is x, right? So in terms of us getting our x values, let's see what we're going to get here. Yeah, this is definitely, I'm busy asking myself what is going on in this brain of mine, because things I'm writing, I'm like, wait, what? Like, wait, what? Where did I get that? No, so it's like negative 2 here times negative 4 minus 3. Yeah, that's a 5, bro. Why are you getting these answers? Sure. Even if I did it manually, bro, I should have at least gotten a 5 there. So here x is also equal to 1. So with 4.3, right, it is given that this, and this, okay, it is proven that these three expressions exist, right? Or it is proven that these three expressions exist. Now they said prove that w is equal to this for 4 marks. So The idea with questions like these is, I mean, there's always, well, obviously we may think some kind of a catch, and yeah, that's not a wrong way to think. Whatever we do, we can see that there are three expressions here. K, they basically has to go some way somehow. So what normally we can do here is, common ground, the 12. So you see here, K, 1 to the power of W, this is equal to 12. A 12 can be written as 3 times 4, right? The good news with that is that we have the number 3 and 4 over here. See, so we have this here as 3, we have this here as 4. So it means in our workings, wherever we're seeing here this 3 and this 4, we can put here K with 1 to the power of X multiplied by K with 1 to the power of Y. And then this is K to the power of 1 to the power of. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. 1 over W. Now the fortunate thing is with this, you see the base is the same, so you can add the exponents. There you go, you can add the exponents. And then here, your bases are the same on two sides of the equation, so you can just drop the bases. So here, 1 over W is equal to 1 over X plus 1 over Y. W, that's the D. Anyway, so let's see, we're gonna need to solve for W, right? The one way to do it is you can get an LCD and then just flip over everything. So what I mean is, you see here the LCD is technically been bigger to XY. So here we need to find a way of like, okay, well, that's not difficult to say. Let's just move this for now, right? So this is going to be times X over X times Y over Y. Now this is like XY. Is it XY? Yeah, XY plus XY over XY. Wait. This is, whoa, what am I doing? Bro. Seriously, the top is going to be Y plus X. At the bottom is going to be XY, 1 over W. The good news is this is a trick you always should know. If you didn't know it, you should know it now. And I'm about to mention it now, right? So if you have a fraction on the one side of the equation and you have a fraction on the other side of the equation, you can just flip them both over. W over 1 is going to be equal to XY over, let's even swap this around because you're plussing, right? And the signs in front of them are pluses. So that the reason for doing that is so that it looks just like what they have there. Yeah. Is it X plus Y? Yeah. X plus Y. And then there you go. There's your question. Question number 2, right? It says an arithmetic series has a common difference, just 4. Yo, excuse me, I'm not even sure if I'm gonna remember to edit out that yawning. So, well, I am. Okay, never mind. Maybe I didn't. Oops, sorry. Wait, what? What's that episode? I don't know. But anyways, An arithmetic series has a common difference of 4. Yes. Then it says 3x minus 4 and 2x plus 8 are the fourth and seventh terms of the series. Yes. So it's like what? They're the fourth. So it's like T4, T7. And they say determine the value of x. Wow. Oh, they said it has a common difference of 4. So it does. So what we need to keep in mind is, okay, there is T7, 6, 5, 4. So the reason why I'm trying to lay this out is because of the following. If you see this is 2x, right? Plus 8. And you see that this is like 3x minus 1. What we know is, because of what they told us, the difference is 4. The common difference is 4, right? Oops. Whoa. Don't tell me that this thing is like, oh, I chose black. Oops. He's writing with black. I thought I broke the pen. Anyway, so the idea is, you see, the difference is 4. So you have to think logically here. What it means is from T4 to T5, you plus a 4. And then from T5 to T6, you plus another 4. From 6 to 7, you plus another 4. So all you know is between here to go there, you have to add 1, 2, 3 times 4. So you see here, all you can now say is an equation. 3x minus 1, right? If you add 12, it will give you 2x plus 8. Literally, you see. So solving for x here, you're going to have negative 1 plus 12, right? It's going to be like 3x plus 11. And then 2x here plus 8, right? If you move the 2x to the left, it's going to be x. 11 to the other side, it's going to give you 8. Minus 11, it's going to give you like minus 3. Is it minus 3? Yeah. Is it? Yeah. 8, 9, 10, 11. Yeah. Moving on, right? They said here we should calculate the first term of the series. So calculating the first term of the series, we can work backwards from t number 4, right? So what we know is t4 is equal to, what did they tell us here? 3x minus 1, right? 3x minus 1. So if that's the case, what we know is x is like negative 3. So 3 times negative 3 is like negative 9. And then this is like negative 10. So if we now know that T4 is like negative 10, remember, working backwards, we're just going to be subtracting 4 all the time. So if this is like, what we know is this is like negative 10, right? Remember, going backwards, we do the opposite of the common difference. So the opposite of plusing a 4, you would be minusing. So here, negative 10, if you minus a 4, you'd get like negative 6. And then if you minus a 4, you would get like negative 2. And then if you minus a 4, you get like what number are you getting now? Ha 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 ha. You get the number 2. You see? No. Wait, what? Did I? Wait. Opposite minus. Wait. If you negative 4 minus 4. Wow. That's like minus 14, bruh. Yo, my maths is so off. Yo, dude, negative 10 minus 4 is going to give you negative 14. Minus 4 is going to give you negative 18. Minus 4 is going to give you negative 22. Yo, that was awkward. That was like proper awkward. But anyways, yeah, because if you work going forward now, so this is, we're working backwards, right? That's what we're doing the opposite. So negative 22, if you plus a 4, you get this. Yeah, if you plus a 4, you get this. If you plus a 4, you get this. So here we can say, therefore, it's so funny. First term is what? Is a negative 22. This is all good. B says the sum of the first 42 terms in the series. So S42, can just use the Sn formula. So it's like Rn minus 1, R minus 1. You see, first term, we know what it is. First term is negative 22. And what is this thing? What is this thing now? R is no. These are arithmetic sequence. It's arithmetic, so we should not even be using this formula. So we should, here we can say Sn is equal to n over 2a plus n minus 1d, and then n is what is n? N is basically the number of terms that you're adding up, so that's 42. A is negative 22, and then d is the common difference, right? Which in this case was a 4 plus 4. So let's just throw everything into the formula. So here S42, I'm going to get 42 over 2. A is like negative 22. N is like 42. D is like 4. And then all this in the calculator, let's see what we're going to get. 2,520 is 42. Okay, let us keep it moving, right? So 2.2.1 says the following. It says the first term of a quadratic number pattern is this much. So the first term is 61, okay? Quadratic number pattern. And then it says here tk, so a certain term, right, is equal to this value. Or rather, this is a formula. It forms the first differences of the quadratic system. Okay, it says write down the second and third terms of the quadratic pattern. Well, I mean, like if it starts at 61, right, what you have to remember is the sequence of first differences is basically the numbers that go here. You see, the number that goes here, the number that goes here, and the number that goes here. So this is the sequence of first differences, because the second one is the one that has a common difference. Or rather, the second thing here would be, these pink ones would be the same, you see. But then these ones here, they are called the sequence, it's called the sequence of first differences. So if it has a formula, it just means that what is in position 1, oh, I'm so sorry, excuse me. What is in position 1, right? This is like 4 times 1, and then minus 26, that's gonna be like so as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning, and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. 4 minus 26, that's like 4 minus 26, yeah, it's like negative 22. That's what goes here, you see, it's like negative 22. And then what's in position number, what's after that is 8 minus this, right? 8 minus this is like yeah, negative 18. Yep, negative 18. And then in position number 3, you have 12 minus 26. What is 12 minus 26? You know. You have like negative 14. What? Negative 14? Serious? Yeah, bro, negative 14. So this is the sequence of first differences. Now what that means is, going forward, you would just be saying this number plus this one, you get this value. And then you carry on basically like that, you see. So in our case here, 61 minus 22, that's going to give you 39, you see. And then if you minus 18, that's going to give you 21. If you minus, so you just need you basically just need they just need the second one and the third one. So that's what you've given them. T2 is 39, T3 is equal to 21, you see. So moving on, you have 2.2.2, right? What does 2.2.2 say? 2.2.2 says the following. It says, if the nth term of the quadratic number pattern is given by this equation, calculate the value of the smallest term. So this is a quadratic number pattern. So it means this is drawing a smiling parabola. So when they ask for the smallest term, you are basically asked for the turning point. That's how you must view it. You see, that's how you must view it. So when you get a turning point, remember, if it was a parabola, you would have written something like x is equal to minus b over 2a. That would have given you like the x value of the turning point. But we want something that's universal. So smallest refers to like minimum. And then remember, we've always said, if you're talking about anything that talks about getting the minimum of this or the minimum of that, then all you do is you need to take whatever equation you're given, you need to differentiate it once, and then you need to make it equal to 0. So that's basically stuff that you'll hear on things like the online courses. But apart from the online courses, I mean, let me just plug you, right? We have like in-person workshops, you see. So the in-person workshops basically taking place in October. They started like 8 in the morning. There's a break in the middle, and then they end off at like 3:30. You see, so currently there's a 2-day workshop that, well, the workshop basically takes place over 2 days. You see, where I mean between paper 1 and paper 2, they're basically spread out amongst those 2 days. Now the location for the in-person workshops, it's 22 on Sloan. The description will have more details, but to attend in person, it's just 999. To attend online, it's just 399. So you see, to attend in person for all those hours, it's just 999, and then to attend online to follow along, it's just 399. Now the idea is, if you sign up for any of these, you automatically get access to all the online courses on our website. So this is the address, right? 22 on Sloan. It's 22 on Sloan. It's in Bryanston, Centon. The postcode is 2191. If you have any questions on this, you can always just let me know. You can always contact me on WhatsApp, whichever way you can. Then I'll be able to clarify, give more information. So on WhatsApp, it's like 063 967 1872. Anyways, let's carry on. So getting the smallest value here, we're saying it's the turning point basically. So we have to differentiate the equation and make it equal to 0. And then solve for x. So let's see here. Differentiating this, is like t n equal to 2 times 2 is 4n. And then 1 times negative 28 is negative 28. And then to move on from the exponent, this falls away. So we say we differentiate and make it equal to 0, right? So 4n here, 28. Move the 28 over, it becomes a plus. Now, what? Divide by 4 on both sides. Divide by 4, divide by 4. This is like 7, 8, 1, 2, 3. What? 4 can 4 get to 28. Yeah, 7 times, bro. Oops, yeah, of course. So n is a 7. And that's the smallest number. You see? Therefore, smallest. They ask for what? The smallest value. Therefore, the smallest value is at position 4. So let me write this a bit better, bro. Come on. Therefore, smallest value is at position 4. No, 7 they said. Is at position 7. Okay, so moving onwards. We have 2.2.3, right? It says a constant k is added to Tn such that all the terms of the quadratic number pattern become positive. Determine the values of k. This is so crazy, but let's read again. A constant k is added. Oh, what I mean is a specific number is added to. Wow. Okay, so the sequence of first differences. A specific number is added, right? Because we're talking about k here. A specific number is added to k such that all the terms of the quadratic number pattern become positive. Determine the values of k. So remember, what you want to recognize is that Tn is just going to be a straight line graph. So Tk is just a straight line graph, because here you can see the equation. It's just 4k minus 26. 4k minus 26. That's the what is this? What is 4k minus 26? 4k minus, no, 4k is equal to 4. Tk is equal to 4k minus 26. So the idea now is it's a straight line graph. This is the kind of a straight line graph that would technically look as follows. You see, so it has an a y-intercept of negative 26, right? It's a smiling. It's a positive straight line graph, so it's gonna look something like that. So the idea is you wanna think of this as, you see, k represents the x-axis, and then k represents the y-axis. That's all this is, because if you want to look at it like a straight line equation, it's just like y is equal to mx plus c. So, or let's just say it's just the same as like saying y is equal to 4x minus 26, like that, you see. So with all that being said, right, we need to be conscious of what it is that we are doing. So if they're saying constant value of k needs to be added such that the terms of the quadratic number pattern become positive. So k is going to be affecting the gradient, basically. So if k is affecting the gradient, then wow, yeah, here we have to just think logically, because if they're saying that all the terms become positive, so they're talking about this becoming positive. So for this, talking about y values becoming positive. So if the y values are becoming positive and k is the one that affects that, yeah, this question is, it needs you to think. A constant k is added to Tn. Oh, Tn, but Tn would not, I think Tn would be representing, oh wait, are we still talking about the same thing? Oh, I'm literally thinking of 2.2. Okay, this is the Tn they're talking about. A certain numbers. Oh man, I'm so lost, but I'm found now. It says the nth term of the quadratic is given by this. Oh, so they're now asking a constant value of k is added to Tn such that all the values are positive. Oh yeah. So that's easy, because now remember, this is a parabola, right? So the way it is, it might have like x-intercepts or intercepts rather, but the thing is, for it to not have intercepts anymore, it needs to be above the x-axis. Now, for it to be above the x-axis, we need to figure out what the y value of the turning point is originally. Because originally, what you're dealing with is something like this. You see, it has a specific turning point over there. The x value here, what we know is the x value is a 7. You see, But then the y value is what we now need to know, because as long as we know the y value there, what we do know is if you move it upwards a certain amount of units, the graph will always have positive y values, meaning it will always have a tn value that's a positive. So firstly, let's find the y value of the turning point. Clearly, all we need is to put in the 7 into the equation of our parabola. So all this, you're watching it, this was just all so far-fetched, like seriously. But anyway, let's see. Tn rather, they say it is equal to 2n squared, and then they say it is equal to minus 28n, and then they say it is equal to n plus 87. Now this is like a 7 squared 87, yeah. So let's see what this gives us in the calculator. See, because why not, right? Why not? So let's see here, calculator. Where's my calculator actually? Yeah, ne? I am literally going through some math, but my calculator is not anywhere close to me. Yeah, that is not being brave, people. That is just being arrogant, because now you see I need it. And now I'm busy looking here. Where's the calculator? Where's the calculator? Whereas if I just had it close, I wouldn't be having this problem. Like, wow, it's gone. Well, I guess we're gonna have to we're gonna have to, what's that word? We're gonna have to use mental math, because, well, okay, I'm sure you probably think we could just pause and just look through the calculator nicely. Okay, fine, let's see. 49 times 2 is like 98, right? 98 plus the 87, and then we're gonna subtract. Okay, so let's see, 28 times 7, right? It's gonna give us 196. And then this plus this, it's like what? 49 times 2, right? It's gonna be 98. 98 plus 87, it's gonna give us 185. So obviously, if you subtract the 196, you're gonna get a negative 11. So negative 11. That's quite interesting, because we would at least be expecting some kind of a positive number. Oh no. We are expecting a negative value, because this is telling us that the y value of the turning point is negative 11. So what you now know is if the y value is at negative 11, what you need to do is, for you to only have now positive values, you need to move it upwards at least 11 units. So the value of k, right, needs to be anything above 11, because k is what you add to your expression for it to have positive numbers everywhere. So here we can say, therefore, k has to be bigger than positive 11. The reason why it has to be bigger than positive 11 is because moving upwards, it's like adding values. So if you add 11 values, then you'd have moved it 11 times going up. If you add more than 11, then it'll move up more than 11, you see. So question number 3 is one of those questions, right? It says, given that P is equal to this is basically 0.777 going onwards. It says, write down P as a geometric series. Geometric series? What? These guys are seriously not serious. Oh, okay. Okay, now I think I understand. So writing this as a geometric series, what you can keep in mind is how you see here, this is 0.7 and another one and another one. So what you can think to yourself is the kind of a sequence you would have, right? It would need to start with like 0.7, but then the next term it would need to have another 7 here, right? So you need to add 0.07. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. And then for it to have another 7 there, then you'd need to add 0.007. If you have to add another 7, if you end up having another 7 here, then you'd have added 0.0007 going onwards this here. So this is your sequence. It starts with this number going on and on and on. And the next one says represent the series in sigma notation. Really? So in sigma notation, you know that this is the symbol. At the top, you know that this is where you end off. At the bottom, this is where you start off. So the thing now is, here you have the formula for Euler. So with that being said, right, the formula, what is the formula going to be? Well, it's Tn to AR n minus 1. Now the idea is the value of A is your first term, right? 0.7. R is just this divided by this. Let's get a value of R. Value of R is going to be 0.07 divided by 0.7. So with that in our calculator, it's just 0.1. So if R is a 0.1, N is just N, because you're trying to get the general term, right? So we know what to put here. In terms of adding up values, we're going to start from 1 going all the way to, but in this case, this is recurring, right? So it goes on forever. So it has to be sum to infinity. So let's see what we then need to put here. So here we're going to put a sigma symbol, goes to infinity, starts when n is a 1. Let's see here. Here n is a 1, so it's like 0.7, 0.1, n minus 1. That's fine. So yeah, that's your sigma expression over there. Nice and dandy. The next one, 3.1.3. What does 3.1.3 say? 3.1.3 for 2 marks says determine the sum to infinity of the geometric series as a proper fraction. Geometric series as a proper fraction. Determine the sum to infinity of the geometric series. Oh, so we then need to get the sum to infinity. Remember, sum to infinity is this a1 minus r. And then a is the first term, right, which is 0.7. R is just 0.1. And 0.7 divided by, this is technically 0.9. So I mean, like so this is like 0.9, right? So both you can multiply them by 10. You're gonna get 7/9. In your calculator also, your thing just gives you 7/9. But anyways, that's fine. In the geometric sequence, the sum of the 9th and 10th term is 6 times the 8th term. Determine the value of R, the common ratio of the sequence. So these are the questions you read and you write what they've said mathematically. So here it says the in a geometric set, the sum of the ninth. So it's T9 plus T10, right? The sum of the ninth and 10th terms is equal to 6 times the 8th term. So this is 6 times the 8th term. Yeah, let's read that again. In a geometric sequence, the sum of the ninth and 10th, so 9th and 10th, is 6 times the 8th. This is determine the values of R, the common ratio of the sequence. So all you do now is remember a general, any sequence, right? If it's geometric, what you have to know is that it looks like this. The first term is A. The second term is A times R. The third term is like A times R squared. And then AR cubed going onwards until forever. So the thing is, term number 1, you see it is R to the power of 0. Term number 2, it is R to the power of 1. Term number 3 is at R to the power of 2. Term number 4, it is R to the power of 3. Going onwards. So term number 9 would basically be like AR to the power of 8. This is basically what you would basically have there. AR to the power of 8. So what that means now is T9, right, is just AR to the power of 8. T10 is just AR to the power of 9. And then T8 is just AR to the power of 7. Now, what that does is, this is like one, now here, if you're going to solve for A and R simultaneously, yeah, you can see here it's just a bit of a problem. So here you have to think strategically. And the one strategy is to take out a common factor, which is AR to the power of 7, you see. Then here you're going to have R. Here you're going to have AR. No. It's going to have R squared. And then you have your 6 AR to the power of 7, of which you can just divide both sides by that. That. And then here, this is going to cancel out. And then here you're going to have R plus R squared equal to 6. Everything on one side, you're going to have R squared plus R minus 6 equal to 0. So factors of 6 that give a 1, it's like 3 and 2. You see, 3, 2, R and R. So to get what? To get a plus 1, it's going to be like plus 3 minus 2. This is equal to 0, right? So here you're going to get R is equal to negative 3 or R is equal to 2. So in this situation, you may be thinking to yourself, okay, fine, does it mean both answers are valid? Well, in this case, yeah, like we're getting two numbers, so both answers are going to be valid. Because the only thing is, if you put them in this equation, I'm like, you don't have the first term, but what you have gotten now is fine. So let's just keep it moving to question number. We're moving on to question number 4 now. Okay, so question number 4. Question number 4 is quite interesting. The reason why question number 4 is interesting, why? Wait, I didn't even see the question. Oh, I'm looking at this format and I'm like, It says in the diagram below, the graph of the hyperbolic function, this where k is a constant is drawn. Then it says a and b are the points, where a and b are the x-intercept and y-intercept of f respectively. The vertical asymptote goes through the vertical asymptote goes through the axis at 3. Yes, this is going through there at 3. A is this point here. Okay. So determine the value of p. P is like, well, p will one or the other always represent the x asymptote. So you don't overthink p, because p is just straightforward. So p in this case, because it's a plus 3 here, it's going to be a minus 3 on the equation. I mean it's going to be minus 3 on the equation, since it is what you may call positive what? since it is a positive on the image, it's going to be a negative on the since it's a positive on the image, it's going to be a negative in the equation. So for 4.1, let's see what 4.1 looks. I mean 4.2 rather, calculate the value of k. So calculating k, we can just put in the coordinates in our equation. So when I say put in the coordinates in our equation, I just mean like we have p already, you know. So if we have p, we might as well throw what you may call everything else that we have. So here, if you see x value is 1, y value is 0. So this is like x and y, right? If you throw that in this equation, y is going to be 0. And then you have x plus k. What is k now? Oh, that's what we're looking for. And then the other one here, it's like p, right? So p, we got it to minus 3. So, I mean, like the way it's laid out now, you may be thinking to yourself, bro, oh, x is a 1. So put a 1 and a 1 there. 1 and 1. So this is going to be 1 plus k, right? The 1 minus 3 is going to be minus 2 equal to 0. So if you times by minus 2 on both sides here, times by negative 2, times by negative 2, this is like what? This is like 0 equal to 1 plus k. So here k is equal to negative 1. Okay, 4.3 says the following. 4.3 says calculate the coordinates of b. So calculating the coordinates of b, it is the y-intercept. B is the y-intercept. So since b is the y-intercept, it means that, what does it mean? Yeah, it just means that b is the y-intercept. So we can just make x as 0 to get b. So in the equation of our graph, the only thing now is with this kind of a setup, you don't even need to worry about the format, because I mean the format can still get you what you want. See, so the format though, the equation is what? F of x. F of x is equal to something. So technically f of x is equal to, what is the value of k? K was negative 1, right? So f of x is equal to x minus 1, x minus 3. So the thing now is, if you're gonna solve for b, you need to make x as 0, you see. So making x as 0, yeah, it's gonna give you something very simple, which is a third, you see. So that's fine. Therefore, the b value is x is a 0, y value is a third. This is all that we need to keep in mind, right? So let's do this. Let's do this. So with everything being said, right? 4.4 says determine the values of x for which this is smaller or equal to 0. So yeah, with questions like these, the one thing I've always said is you need to know what these expressions mean, you see. So yeah, determine the values of x for which x times f of x is smaller or equal to 0. So x represents x values, y represents y values. I mean, x represents x values, f of x represents y. So they're talking about the equation of f, right? So they're basically asking you, if you multiply out these two things, where will you be getting a number that is smaller or equal to 0? So if you think of it nicely, when you multiply two things together, right? One thing multiplied another thing. The only way you're going to get a number smaller than 0 is if one of them is a plus while the other one is a minus, or if one of them is a minus while the other one is a plus, you see. So with that being said, right, all we need is, let's color code our sketch, you see. So color coding our sketch, we have to be careful. So color coding our sketch, what we do have here, or let me use blue and red because it's like, you know, classic. So red, we're gonna put negative, let's put negative. So remember, we're dealing with X values and we're dealing with Y values. So let's color code where we have negative X values. Negative X values is here. And then let's color code where we have negative Y values. Negative Y values is here. Okay, fine. Let's deal with the positives. Where we have positive X values, it's over here. And then where we have positive Y values, it's over here. And then obviously over there. Yeah. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. You literally want cases where the stuff is like mixed up or swapped around, where you have 1 plus 1 negative. So in a situation like that, you can see here, we want a situation where we have a positive X value while having a negative Y value. We want to also have cases where we have negative X value while we're having positive Y values. So the only scenario where we at least have something that qualifies for our answer is from 0 going to negative. It's from 0 to negative infinity, and it is from 1 to 3. You see, from 1 to 3, you can see you have this negative Y values, and then you also have this positive X value. Here you have this negative X value, and then up here you have these positive Y values. So let's use that. So with everything that I have been talking about, right? The one big idea is the following. So the one big idea that we need to keep in mind now is if you're going to give your answers, you're going to need to say X is smaller, or in this case you can say smaller or equal to 0, and then here you can say X is bigger than 1, bigger or equal to 1, and then X is smaller or equal to 3. The reason we're adding this equal to and this equal to and this equal to is because specifically at 0 there is an X value of 0, so anything times 0 is a 0. Specifically at 1 and 3, you know, our Y values are 0. I mean our Y values are 0, so 0 times anything will be giving us the 0 that we know we need to at least get. So let's take these answers and drop them where they belong. So you can see the way you answer these questions is you need to know your work. But anyways, the 3, no, the 3 is not included. The reason why the 3 is not included is because specifically at 3 there's an asymptote, you see. So we need to be mindful of that. So that's why we're not including the 3 specifically, because it's going just before the 3, technically speaking. So yeah, 4.5 says rewrite the equation of f in this format. Well, that one is something you need to be able to, well, you may be asking yourself, how do you even do that? Like, how do you even do that? Well, this is like one of those cheat questions. When I say cheat questions, I just mean, yeah, they're usually just weird, because in terms of you like answering this kind of a question, if you think of what we are starting off with, right? F of x equal to x minus 1, x minus 3. So this is one of those questions that kind of show you that the game is rigged. Because the thing is, when you get questions like these, this is what you need to keep in mind. You need to keep in mind that the reason why they're giving you questions like these is because at grade 12 level, there is basically one method that you can use to try and like justify how this can be put into something like this. So the first thing you want to do is you want to look at the bottom, right? And you want to identify what is at the bottom. You see you have x minus 3. So the idea now is you want to somewhat rewrite the top in such a way that x minus 3 is there, but you don't want to neglect the negative 1. So fortunately, the x is there, the x is there. So one way or the other, you want to write negative 1 in terms of negative 3. So what I mean is, to get a negative 3, you can just say, you need to find a way to get negative 1 from negative 3. So to get positive 1, to get negative 1 from what you call negative 3, you have to plus a 2. So what happens is, for the top, you want to rewrite it in such a way that you have at least whatever you have at the bottom here, you also want to have it at the top, because when they do ask you questions like these, 99.999% of the time, your value of q is a 1. So it's already something you'd be thinking of. And you'd be saying to yourself, okay, fine, for me to end up with this, I need to at least start with like 2 terms, where 1 eventually like becomes whatever this value is, which is, as we said, a 1. So what you do is, at the top, you write it as x minus 3, right? Put together in some brackets. And then here you have to minus a 1. Oh, no, plus a 2, actually. The reason for plusing a 2 there is because this is the only way you will end up with the minus 1 that you have there. You see, because if you plus a 2, negative 3 plus a 2 will give you this negative 1 over there. So the bottom part, you're going to get x minus 3. So if you're going to get x minus 3, let's see, so it's like negative 1, negative 3 plus 2. So negative 3 plus 2 is like negative 1. So x minus 1, x minus 3. No. You can see it goes there, so you're fine. So what you then do now is you want to split these up. You want to split it up. Remember, it's like 2 terms. You want to view this orange one as like one term, and the other one as another term. So you're going to have here f of x is going to be equal to x minus 3. And this is like 2 over x minus 3. So the big idea here is this you can write first. So 2 and the x minus 3. This over this is just going to give you a 1. That's f of x. So if you have gotten your f of x, then how many marks? They're only offering 2 marks. So you can see why they're only offering 2 marks. The reason why they're offering 2 marks is because firstly, they don't want you to lose out on too many marks for one question. Secondly, they know that you're not going to do a lot of crazy stuff, because the method is roughly always the same. Question number 5. Okay, question number 5. Question number 5 says, given the function f of x is equal to negative 3 to the power of x plus 1. So in a situation like that, right, you need to be careful. When I say careful, I just mean, it's an exponential graph. Okay, there's really not much to be careful about. Just get your marks, actually. So we're given this equation, then it says write down, or it says draw the graph of f, right, in your answer book. Okay, clearly show the intercepts with the x's as well as the asymptote of the graph. Oh, this is not so bad, because it's not so bad. So your Cartesian plane just look something like that. Now the thing with an exponential graph is the asymptote is something you can always see first. So at +1 here, right? That's like somewhere here, +1. And then what we do know is because it's a -3 here, it means as your x values are getting higher and higher and higher and higher and higher. Remember, this is what any exponent here, if it's a positive number, right, it's going to be making the value here go bigger and bigger and bigger and bigger. But then the moment you put a minus here, it's just showing you that whatever this is, if you put a minus there, you will just be getting a lot of negative y values. So our graph, okay, actually you can just get an x-intercept and a y-intercept if possible. So in this case, we do see that it's potentially can have both. Well, it is, but let's just see. Your x-intercept, you make y as 0, right? So you'd have said y is equal to -3x plus 1. The -3x would have gone over, and then this is what you have, right? And then your bases are the same, so it's like 3 to the power of x, 3 to the power of 0. And then here you can say therefore x is equal to therefore x is equal to 0. So yeah, your x value is equal to 0. Meaning what, my guy? Meaning what? So if your x value is equal to 0, right? So what that means is where x is a 0, well, this one I think it's gonna be one of those things where the x-intercept is also the same as the y-intercept, because if you make here x as 0, right, you're gonna have -3 to the power of 0 and then plus 1. So remember, anything to the power of 0 is a 1. So it's like 1 with a negative, that's -1. So -1 plus 1 is 0. So this is both an x value and a y value. Now, judging from how this is behaving, remember, as long as x is getting higher and higher and higher, you're going to be multiplying by negative. So it's just going to get lower. This graph is going to look like this, basically. You see? Because one way or the other, your graph is what? And it is what it is. It is what it is. This is an exponential graph. It's going down like that. So yeah, that's all good. Let's keep it moving, keep it moving, keep it flowing. Let's label it f of x. So yeah, we've labeled it and we can keep moving forward now. 5.2 says write down the range of f. So if we're gonna write down the range of f, well, range means y value. So the y value here is what? It's a positive. What's a positive? This is a positive what? Oh, it's a positive 1. So the range is which y values the graph goes to. We can see it stops at 1. Everything down, it goes to it. So the range, you have to say the y values have to be smaller than smaller than 1. It does not touch 1 because it's the asymptote. So anything below 1. And then 5.3 says determine the equation of the asymptote of g if g is negative f of x. So negative f of x is like negative 3x plus 1. So it's going to be like positive 3 of x minus 1. So this is what g of x is, you see. So the equation of the asymptote, you're going to say y is equal to -1, because this is going to be the equation. This here represents the y asymptote, which is the only asymptote that an exponential graph has. So the next question here says, if g is shifted 1 unit upwards to give a new equation h, determine the equation of the inverse of h. So firstly, if g of x is moved 1 unit upward, it means this is what the equation would look like. G of x plus 1, you see. So the equation of g of x, whatever it is, you would need 2 plus 1. Meaning the new equation, which we know it's h, it's just going to be 3 to the power of x. So getting the inverse of this, what we know is x becomes y, y becomes x. So this whole thing here becomes your x, this here becomes your y. And if you're going to make y the subject of the formula, remember, making y the subject of the formula, if it's an exponent, you're just going to say y, you write it as the subject of the formula. You say y is equal to log, and then whatever base that is, you see. So that's all you need to keep in mind for this kind of equation. The inverse, they did say they want it in that format, so you can put it like this, and then you can say log x. Wait, no? Bro, come on, man. The base of the exponent, which is 3, becomes the base of the log. This other number comes here. So in this case, base of the exponent is x. The other values, like what? No. Base is 3, bro. 3 and then x over here. Fine. Everything looks lovely. That's the way we love it. Let's move on. Question number 6 says, the diagram below shows the graphs of f of x is equal to something, and g of x is equal to the first derivative of f. And then it says a and b are the x-intercept of a and c in the x-intercept of g. Wow. Okay, so they mean like there's an x-intercept here, and then there's another for the parabola. There's an x-intercept there and an x-intercept there. Okay. So with all this being said, right? They then told us that D is the turning point. So it looks like D and C have the same x-intercept. I mean the same x value, but we don't have any information of that, so we might as well just leave it. And then it says here, and G of H intersect at M. Who is M? M is an incomplete coordinate, so obviously at some point in time we can expect to ask us something about this M. And then N is like 7 and 10. Okay, fine. So it says calculate the coordinates of D. The turning point as we mentioned. Is there an equation given? Yes. Oh, finally, at least. So D, you can just differentiate and equate it to 0. So because that's the what? That's how you get the x value of the turning point, and then eventually to get the y, you can just throw in the stuff into the original equation. Or I guess they're just doing it for, let me see here. X squared minus 4x. X squared minus 4x. And then minus 11. And then, well, first derivative, bro, come on. I just rewrote the equation. First derivative is going to be 2 times the one there, which is like 2x. And then minus 4, right? So you're going to, if you differentiate minus 4, it's like 1 times negative 4, which is like minus 4, like that. Yeah. And then, yeah, you need to make it equal to 0, right? 0 is equal to 4, equal to 2x minus 4. The 4 goes to the other side. And then divide by 2 on both sides. Divide by 2x 2. Now that you have an x value, you can get a y value by throwing x into the original equation. So in the equation of f of x, we're gonna throw a 2 in there. So let's throw a 2, and then let's see. So after throwing a 2 in there, we're having a what's going on now? Yeah, x squared minus something. X squared, right? Minus 4x, and then minus x, and minus 11, I mean. So if we're gonna throw 2 wherever x is, right, then you're gonna have here 2 squared, and then you're gonna have here 2, which is after the 4. So there's like 4 minus 8, which is like 4 minus 8. Isn't it like minus 4? Yeah, so it's like minus 4 minus 11. bro, come on. That's going to give you negative 14. You see, so yeah, so far so good. Also, it is definitely one of those things. So with the next questions, right? Let's see what they're asking us here. So 15. So wait, let me see. Let me just try and see if I made a mistake here. Negative 11. What is 4 minus 2? Well, I made a mistake. Oh yeah, 4 minus 2 is minus 4. Ugh, dude, it's minus 15, bro. Come on. Are you joking? Like, seriously? I keep looking at the answer that I wrote and I'm like, wait, what? How can negative 4 and negative 11 be something else? But yeah, it cannot. So anyways, so for 4 marks, we need to determine the distance of Cn. So the big idea about Cn, as I mentioned, when did I mention? Whichever way. So with Cn, we can see that C is a point on the straight line, and then N is a point on the parabola. So with the straight line, the unfortunate thing is we don't have any pieces of information. But I mean, we actually, wait a minute, I actually don't even think I should make this complicated when it's really not, because these two graphs, they intersect at N and at M. So if we're gonna get the distance of Cn, we might as well get, it looks like we can get T first. What is this thing here? Is this a T? It's a T. We can get T because I mean, like, we have the equation of the parabola anyways. So we can get T. The reason for that is we can just get the equation of the straight line, find out what C is, and then use the distance formula to get Cn. So I don't think that's a big deal. So let's get T. So in the equation of the parabola, let's see what the y value is, where x is a negative 1, you see. So we have negative 1 there, squared, minus 4, negative 1 over there, and then we have here negative 11, right? So all this in the calculator, you'll see it's like 1 squared is a 1, negative 4, negative 1 is positive 4, negative 11, 5 minus 11 is like what? Minus 7. No, minus, 6, bro. Minus 6. Yeah. So now that we have the value of T, so as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. We can basically move forward with our agenda, you see, because now we can get the gradient of mn, right? So let's do it. Getting the gradient of mn, you know, that is going to be again y2 minus y1, x2 minus x1. So in this situation, we can say 10 minus negative 6, meaning we're going to plus, and then here we're going to have 7 minus negative 1, meaning we're going to plus. So this is going to be like 16 over 8, which is like a 2. So obviously, with this thing mentioned, right, we have the gradient of Cn now. We said we need to get the equation of Cn. So what we know is that y minus y1 is equal to mx minus x1. So the gradient is, we said it's a 2. X1 and x2, I mean x1 and y1 represent the coordinates. So we can use 7 and 10 here. So you can say y minus 10, x minus 7. You see, this is going to be 2x minus 14, y. If this minus 10, we can take it over, right? It becomes plus 10. So here y is going to be equal to 2x. Negative 14 plus 10 is like negative 4. Let's see if that's, yeah, sounds like, so if this here is like negative 6, this being negative 4 is definitely believable. So now we can get C. Okay, so C, we can make x a 0 in the equation. Oh, so here we can say, whoa. Yeah, if you make x a 0 here, I mean, if you make y a 0 rather, to get the x-intercept, let's see, 0, 2x minus 4, the 4 goes over, divide by 2 on both sides, you have x is equal to 2. There we go. So C is the coordinate of C. Coincidentally, oh no. Coincidentally, x is a 2 here. So 2 and 0. Therefore, Cn, just use the distance formula. Because, I mean, why not, you see? Square root x2 minus x1 squared, y2 minus y1 squared. So let's see, which coordinates do we have? Okay, so it's like we can say 7 minus 2, so it's like, 7 minus 2 squared plus 10 minus 0. So it's like 10 minus 0. And then let's see what we should do next. So obviously from here, we have 7 minus 2 is like 5, right? So yeah, risky business. 5 squared is like 25. 10 squared is like 100. Square root of 125. So square root of 125 is basically our distance of Cn. So one way or the other, we can, yeah, so this is what we have. Nothing crazy, nothing major. 5 times this, we can write it as 5 times 25, which is 5 square root of 5 basically. So let's just carry on, because why not? 6.2 says the following. 6.2 says, for which values of x is f of x below g of x? So with a question like this one, yeah, let's see what we can do. Let's see what we can do. So well, what do you remember? Let's see what we can do. So this, we obviously need our sketch. We need the whole sketch here. So let's take this sketch here and let's paste it over here. You see. So with our sketch here, what we know is f of x represents the y values, g of x represents, f of x represents y values of f, this represents y values of g. So this is asking where the y values of f below the y values of g. So what you normally do is go to where the graphs meet. And then if you look at it nicely, the f of x, where are they below the graph of g? So y values of f, you can see here, these y values of f, right? They are above these y values of g until this point they're equal, and then they swap around. The values of f here are now below. See, they're down here, and then the values of g are up here. So this is where the graph of g is above the graph of f. It's starting from this x value up until this x value. So between -1 and 7, you see. So here we can say x is bigger than -1, but then that same x value is smaller than 7, which is what we have there. The next one says, well, for each value of x is g of x minus f of x a maximum. So this is not a strange question. All you do is, remember, this here is an equation. So you take that equation, and then since they're asking whether that equation is a maximum, what you do is, whatever this equation is, right, you're gonna differentiate it and make it equal to 0, because anytime they ask for the maximum of something, remember, within the online courses that are on our website, the link to that in the description, right, the one thing you always hear in the calculus course is that if you're going to need to work out the maximum or the minimum of something, whatever equation that is, differentiate it and make it equal to 0. So the graph of g, fortunately, we already have the equation of g here. You see, 2x minus 4. So here we can have the 2x minus 4, that's the equation of g. The equation of f of x, remember, if you're going to minus f of x, it means all of this is going to change. So you're going to be having negative x squared plus 4x and then plus 11. So let's do that, right? So we're going to have here plus negative, so we're minusing f of x, so minus x squared, and then it's going to be plus 4x and plus 11. So let's write that out, plus 4x plus 11. So this is the equation we're dealing with, right? So they're asking where is it a maximum. So what you do is you can simplify the equation first. So you see negative x squared, 4 plus 2 is a 6, and then 11 minus 4 is like 7. Positive 7. So now you can differentiate this equation. So here you can label this, this equation, what can you give it? You can just, what you do know is when you differentiate this equation, you can put d over dx, right? And then you can say 2 times the negative there is -2, and then x, then plus 6. So making it equal to 0, it's going to be -2x plus 6. The -2 goes over, so you're going to have here, divide both sides by 2. There you go. So with this being said, right, let's see what we need to do next. So 6.2.1, we did that. So all this is all nice and dandy. So we can move on to the next question. Question number 7. It's a 2-mark question. It says, Cornel bought an ice cream machine that depreciated at 17% per annum on the reducing balance method. The value of the machine depreciated to a book value of 27,000 over a period of 4 years. What was the original price? So if we're talking about something depreciating and they said reducing balance, this is the reducing balance formula. You see, this is something we should all know. So the percentage, we already have it. The figure after the 4 years, we already have it. So original figure is P. See? So whatever P is what we're looking for. So let's work out a value of P. So here if you're gonna isolate p here, I mean, like, we're gonna divide by 1 plus I to the power of n. Divide this side by 1 plus I to the power of n. And then that's what p is, right? P a 1 plus I to the power of n. So A is 27,000. So it's like 27,763, right? 0.12. And then let's see, interest. What is interest now? Interest 17% per annum, right? So here you can even just say 0.17 because divided by 100, that's what you're gonna have. Or you can just say 17%. Just don't forget the symbol. So because it's over a period of 4 years, they didn't say anything about compound monthly, so it says per annum. So put a 4 there. Let's see what P is gonna be. P, so in the calculator, our value of P here, this is, what are we getting in this calculator? Well, this answer is looking very nice because at the same time, well, yeah, so this with what we have now, right? Let me see here. Oh, wait. I put a plus. Busy making a mistake here. Because that's why I'm like, no, this answer looks so weird. Yeah, oopsie, the typo there. Yeah, so now this is giving us 58,500. 7.2 says, after completing his studies, Lubabalo decides to save money to buy himself a car for cash. He wants to save 300,000 by making equal monthly deposits into a savings account that pays interest at 8.6% per annum compounded monthly over a period of 7 years. How much must he deposit per month if he wants to achieve this goal? So it's a normal monthly installment question, this one. So we don't need to overthink it. Otherwise, we're just going to be doing ourselves an injustice. So solving for x here, which is the monthly value, we can just isolate x here. So we can multiply by I there, multiply by I. Meaning we're going to have fi. So this cancels that. And then this like x 1 plus I to the power of n minus 1. And then divide everything by the big bracket. So that's what we're going to get here. 1 plus I. Let's see what we get here. Yeah, and this cancels that. So it's like f. Oh, this also you divide by the big bracket. You see. 1 plus I to the power of n minus 1. Oh, sharksify. So here's therefore, so our x value, right? Go to fi 1 plus I to the power of n minus 1 close bracket. There we go. Yeah, so that's what you need to keep in mind, you see. Whoa. So with having to written it like this, it allows you to make less mistakes because it just allows you to put everything in the calculator. So our f value is 300,000. That's the amount we are looking for at the end of the day. So because our interest is compounded monthly, our value of I has to be the interest, which is 8.6% divided by 12. It's over 7 years, so n is going to be 7 times 12. So that's basically the two key things we need to keep in mind. The rest we can just, I mean, it's straightforward. So f here, 300,000. Interest, what is interest? 8.6%, right? Over 12. The whole thing over, whole thing here. Interest is like 8.6% over 12. what is n? N is 7 times 12, right? Which is like 72. Is that what 12 times 7 is? Yeah, getting a blunt. It's not 8. It sounds too small. I think it's like what 6 times 5? No, man, it's like 84, bro. Yeah, 84 sounds a bit more. Yeah, 84 sounds like it has a bit more oomph. 72 just sounds way too small, like seriously. 72 sounds way too small. So 7 times 12, yeah, 84. And the minus 1 here. So x here is equal to, let's see what we get here. So yeah, so with everything that we're getting here, in the calculator, we're getting here 2,616.05, which is okay. Nothing too crazy for this question. The next one says, Yolanda required a mortgage loan to buy a house. She was required to pay this much monthly, and she was charged 10.4% interest per annum compounded monthly. Her payment period was 25 years, and the first payment was made at the end of each month after she took the loan. So there are no months that she skipped or whatever. Then she's calculated the value of the mortgage loan to the nearest rent Yolanda needed. Oh, so here we are we're being asked to work out a value of P, because one way or the other, they gave us everything else. You see, they gave us the interest rate, they gave us the monthly, they gave us the years. So this is just a straightforward question where they want us to get the value of P. So X is gonna be 8,901.96. Interest is like 10.4%, right? So 10.4% over 12. What do we now get here? N is what? 25. So 25 times 12 is like what? Let's just write it like this: 25 times 12. And then what else? At the bottom, same idea. At the bottom, interest is 10.4%, right, over 12. Yeah. Let's see what we're going to get from this question here. So in the calculator, whoa, bro, where's the minus 1 here? Come on now. Why are you adding extra stuff now? Let's try that again in the calculator. Okay, this is quite a straightforward number. I mean, like, clearly, if you round it off to the nearest whole number, which is what's logical here, it's going to be 950,000. Yeah, 950,000, because 949,000.99999. I mean, like, it is what it is. So moving on, it says, after 204 payments, Yolanda could only afford 7,500 per month going forward. Determine the outstanding balance after the 204th payment. So the thing is, if you're gonna get the balance on a loan, there are two ways to do it. The main way that I always use is the A minus F formula. That's how you can get outstanding balance on the loan. Because if you use this formula, right, so balance is equal to A minus F. But then here, you will use it based on the number of payments that have been made. The other formula for balance, you can just say balance is equal to, it's actually technically the what you may call the P formula, but then N would need to be the months remaining. So X, and then you have 1 minus I plus negative n. This here, right, you have to keep in mind that n is basically the months remaining. So here n is months remaining. The months remaining. So in our case, technically speaking, right, out of 300 months, if you remove 204 months, there's 96 months remaining. So we can use that to get the balance. See, the balance on the loan. Actually, no, wait. This does not make sense because the monthly installment is still the original one. The reason why the monthly installment is still the original one for this calculation is because within these 200 and something payments, this is the monthly installment he was making. The 7,400, that's just what they told us they are going to want to start paying. So we have to use this value here when we're getting the balance. So let's put that in the calculator. In the calculator, we're getting here 578,551.24. There we go. So seems like we have done what we can. Let's move on to the next one. It says, how long did it take for Yolanda to pay up the outstanding balance if she was allowed to pay the new installment? So her new installment is 7,500. So if they're asking us how long does it take her to pay, we can just use the normal P formula. But in this P formula, what we know is we need to isolate n. You see, which is what I always say you can do when you work out n. Just isolate n first because it helps you to not need to round off values and all that. So you see here, times by n times by I. It's gonna give you cancel I there. Then it's gonna be pi x 1 minus 1 plus I negative n, right? Since it's solving for n, you can divide both sides by x here, x, and then 1x cancels 1x. So this is like pi over x, right? 1 minus 1 plus I negative n. So this whole thing here, we can take it over, it becomes a plus. And then this whole thing here, we can take it over, it becomes a minus. And then obviously we're trying to work out n, right? So you make n the subject of the formula, it's gonna give you log. The base is gonna be this number, 1 plus I, and then 1 minus pi over x, right? So the whole thing is the negative here. You see this negative, if you divide both sides by negative, it won't be this side anymore, it will be this side. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. So with that being said, and if you now put in the numbers, right, log, the interest is, what is the interest? The interest is, whoa, what is the interest? Is it not 10.4%? Yeah, that hasn't changed. So it's still just going to be 10.4% here. 10.4% over 12. And then we have like 1 minus P. P is like what? P is the amount that we're paying off, right? Which is the amount we got in the previous question. That's the balance on the loan, because that's the amount he owes, you know, before he changed his installment. Well, where did the answer go now? Yeah, so our answer here was 578,551.24. So here, that's the number we're going to use here. 578,551.24. Interest rate is 10.4% over 12, right? And then the whole thing here, I'm gonna put it over, we'll see now. Oh, this is over X, right? So X is 750,000. I mean 7,500. So let's put all this in the calculator. Let's see what it is getting us. So our value of n here, oh, negative, forgot a negative. That's why it's coming out as a weird number. Well, just put the same thing. Let's see here. We're getting n is equal to, in this case, it's going to be 127.97. So if you round off, it's going to be, therefore n is equal to 128. There you go. So let us move on. We're moving on to question number 8 now. Question number 8. So question number 8 it is what it is. It's a normal generic first principles question. So nothing crazy there. We just have to think of our first principles formula. This is what it looks like, you see. Lim h goes to 0. Fx plus h minus f of x, right? The whole thing here over h. So the big idea here is that, let's see, lim h goes to 0, right? So what you need to keep in mind is, well, obviously, wait, no, let's not do this. So here, what we do know is fx plus h. This is what you need to actually get first. So meaning in the equation of f, wherever x is, you put x plus h, which is over there, right? So minus 3 x plus h squared. And then if you multiply the negative 3 inside, it's going to be negative 3x. Oh, bro, such a dumb classic mistake. Come on. So here, if you FOIL out this bracket, it's going to be x squared plus 2xh plus h squared. Now here, we're going to have x minus 3x squared minus 6xh minus 3h squared. So with that being said, right, let's see here. There's nothing much to do here. So we can just now take this entire thing into our original question, because you see, where f of x plus h is, you have to throw this whole thing here. And then minus f of x means you have to put in minus x and then plus x squared. So let's see. First principles, or rather first derivative, is going to be lim. The whole h goes to 0. We have to always put that there. So this whole thing here is going to go where x plus h is. Put that there, paste. Let's even use maybe the color that they are telling us here. Let's use this one. And then here we have minus f of x. So it's going to be negative x and then positive 3x squared. The whole thing here, h. Now, what we already know is that these things should be starting to cancel out. You see, this cancels this cancels that. If you don't find yourself canceling, it means that there's something wrong. It means that you made a mistake somewhere. So you always just want to be conscious of that, always and forever, you see. So you have here negative 6xh minus 3h squared, whole thing over h. And then here it's like lim h goes to 0, negative 6x minus 3h, and then here you can have h. So here this h cancels this h, and then it's like lim h goes to 0, negative 6x minus 3h. And then from here, obviously, you can throw the 0 where h is now. Then you're going to have the first prime is going to equal to negative 6x, which obviously is the correct answer, because if you look at what you have in the beginning. No, I forgot the plus 1. Yeah, something is wrong. Yeah, there's supposed to be a plus 1 somewhere. Reason is, if you differentiate this, it stays with the 1. So that's why I'm thinking, where did the 1 go now? What a wow, bro. Where did the 1 go? Wow, this is awkward. Very, very awkward. But let's look again. Let's see. This times this times this. So here this goes away. This. If you take out an x, and take out an h, you can have negative this 3h squared. This cancels this, and then you have. There's supposed to be an bro. This is looking awkward. This is looking super awkward, super duper awkward. Yeah, there's an H missing somewhere. Oh my goodness. There is the error. Oh, it's a big one. Sure. So awkward. But why am I putting X here? It's supposed to be X plus H here also. Wow. Yeah. Okay, we're not gonna change everything completely, but yeah, there's a dumb mistake. So what that did is, yeah, it just derailed everything. And you can see why also it's important to double check your answer. Because if I didn't double check, I would not have seen this error. So here it's supposed to be x plus h, and x plus h over there in these three spaces here. So it's going to be x plus h, x plus h, x plus h. So here you'd have, instead of just having x here, right, we said we'd have x plus h, meaning this x would still cancel this one, but then we'd have an extra plus h here. Here would have had a plus h, but then if you take out h, you'd have had a 1 here. And then here your plus 1 will be there, and then your plus 1 will be there. There we go. So don't leave things to just slide if it's not making sense. See, so yeah, that's one thing that's kind of interesting, because here I don't know, it slipped my mind that this is also x. You know, it's always easy to just put the x plus h on the big one, but yeah. So I guess you can always look out for those kinds of errors. You know, always double check your answer, and yeah, just do your best. So let's move on to the next question. 8.2 says we should differentiate this equation. So differentiating this equation, you need to, what you may call, differentiating this equation, right? You need to, yeah, let's see, you have to simplify first. So simplifying, you're gonna have the 3x to the power 4. The x squared goes on top, right? So it's like 4x negative 2. And then you're gonna have here this part here, dx. Let's see, if you differentiate this equation, now you can see this, if you differentiate it, going to be like 12x to the power of 3 plus 4x negative 3. You see? No. So it's like negative 2 times negative 4. That's like positive. So it's like 8x to the power of negative 3 like this. So yeah, this question doesn't seem like there's anything to it. We can just move on with the question. So the next one, let's see. It's also a 3-mark question. So if you're going to differentiate in terms of x, don't even worry about the a, because the a there is just a coefficient. So differentiating this, it's going to be 1 times a squared, which is like a squared. 1 minus 1 is just a 0. Wait, before we differentiate, let's just simplify first, because, you know, yeah, let's not be arrogant. So there's a 2 here, there's a 1 there. You see, invisible 2, and then it's invisible 1. So the number there has to go under the 1, because you can only differentiate if your terms are all in this format, you know, a coefficient, a base, and an exponent. So here, our coefficient is 6, our base is going to be x, our exponent is a half, because the 2 that is here and there's a 1 that's there, you see. So with that being said, let's see what we can do here. Let's see what we can do. So let's put the green lean machine. So here, differentiating, right, we have 1 times a squared, which is a squared. Half times 6 is like 3. A half minus 1 is like negative a half. So this is what we have here. So this is what our dy over dx is. Dy over dx. Yeah. So let's keep it moving. Like the water. So moving on, right? So again, obviously, the online courses that will help you prepare for your exams, the link to that is in the description. So that's for like detailed explanations of all these topics here. So let's move on to question number 9. Question 9 is a calculus question. So let's go with it. 4 marks, they say, determine the coordinates of the turning point of f. F is just a normal cubic function. So a turning point, I mean, it's just the first derivative. So the first derivative is going to be equal to 3x squared, and then like minus 3 basically, because that's your first derivative. Because 1 times negative 3 is just negative 3x. With 1 there, minus 1 is going to be x above 0, so it's just a 1. Differentiate a constant, it falls away. Here, 3 times the value in front is a 3. 3 minus 1 gives us a 2 there. So at turning point, you differentiate your equation, right, and you make it equal to 0 to get the x values of the turning points. So here the 3 can go over, it becomes plus. Divide both sides by the 3 there. Meaning, you see, divide by 3, you're going to have x squared is equal to 1. If you square it both sides, you're going to have plus or minus what you may call plus or minus 1, which is okay. So the x values are a negative 1 and a positive 1. So since they want the coordinates, you have to get the y values also. So you see here, negative 1 here, cubed, minus 3, negative 1 plus 2. Then this is like what? Negative 1 plus 3 plus 2. It's like negative 1 plus 5, right? Which is like a 4. There we go. And then the other one here, you put a 1, right? This is actually a coordinate, so you can say negative 1 and 4. The other one, if you put a 1 there, 1 to the power of 3, 3 times 1 plus 2. This is like 1 minus 3 plus 2, right? So it's like 1 plus 2 is 3. 3 minus 3 is a 0. So therefore 1 coordinate 0. So this one makes our life quite interesting because it's a turning point that's also at an x-intercept. So if you don't yet know what that means, I mean, you definitely need to enroll in the online courses, like without a doubt. The link for that is in the description. So here for 3 marks, they said calculate the x-intercept of f. So fortunately here, calculating the x-intercepts, right, it needs you to be able to use long division. F of x is equal to x cubed minus 3x and then plus 2. This is the equation, right? Now, before you can do whatever you need to do to factorize here, you need to keep in mind the following. So the idea is, if you're going to make this, if you're going to solve for x here, you need to find at least one factor. And this is where knowledge of this comes into play, because this is an x-intercept, right? This here, because the x value is a 1, the y value is a 0. So if one of your x-intercepts is equal to a 1, what it means is when this is factorized, right, one of your brackets is x minus 1. So what that does is this x minus 1, you can use it to get the rest of the x-intercepts. And this is how you do it. The first thing is you want to make sure that your equation is in standard form. So standard form means that you have to have an exponent of 3, an exponent of 2, and then an exponent of 1. And then you see here, this is technically having x to the power of 0. So when you write it out, you can put x to the power of 3. Since there's nothing with x squared here, you can put plus 0 x squared, and then here minus 3x, and then plus 2. So with all that being done, right, what we do know is the following. What we do know is the following. When we want to use long division, right, what we do is this number here, you write it up, you write it somewhere here, and then the coefficients of your equation, right, you're going to take each of them. So the coefficients, we have like 1, 0, -3, and then +2. You see, so you're going to put those coefficients one after the other. So there's going to be a 1 here, a 0, a -3, a 2. So with that being said, right, what we know is you're going to leave a line open. Going to leave a line open over there. And then what you do is, this is what you do. You drop this number, right? This number here, you drop it. So you're going to drop it over here. And then this is where the magic starts to happen. So in terms of the magic happening, right, you're just going to be multiplying and then adding, multiplying and then adding. So for example, all you do is you drop this number, then you start 1 times 1 is a 1. Then you add these numbers. 0 plus 1 is a 1. And then 1 times 1 is a 1 again. Then you add these numbers. -3 plus 1 is like -2. And then 1 times -2, like -2. Then you add these numbers. This is going to be a 0. So the thing is, this number always has to be a 0. It always has to be a 0. So what you have done now is, in your equation of f of x, what you know is f of x, right? Firstly, this is one of your brackets because of this x-intercept here. You see, because if x is a 1, this you can write it as a bracket. So when you factorize x minus 1 is one of your brackets, the other bracket will have this as the coefficient of x squared, this as the coefficient of x, and then this as your c value. You see, now what that does is, now you can see your x-intercepts already. You have this first one, right? X is equal to x is equal to x minus 1 is equal to 0, or, because remember, with what you would have written out here, solving for x, right, you make this equal to 0. X minus 1, x squared plus x minus 2. So this is equal to 0, or x squared plus x minus 2 is equal to 0. So the thing is, with this equation here, what we know is factors of 2 that give us a 1. It's 1 and 1. So, okay, but this one we cannot necessarily, it's not something we can factorize from the top of our heads. So we have to use the no, we can't, bro, come on. So 1 and 1, to get a +1, no, 2 and 1 can give us a 2. So 2 and 1. To get a plus 1 here, say plus 2 minus 1. There you go. So here x is equal to -2 or x is equal to 1. So that's what we need to do. Now here, 1 x-intercept, second x-intercept, third x-intercept. So that's that for this kind of a question. No, come on, bro. We already have x is equal to 1, but we have it twice, so that's still fine. It just means we have 2 x-intercepts. So with all this being done, I'm gonna even remove these things for now, just, so you're just gonna get 1, 2, that mark for your calculations, because this is a 3-mark question, right? So you can see this is important. If you are not familiar with long division, again, you see it basically does show that you need to sign up for the online courses. So the fortunate thing is we do have a workshop coming up, an in-person workshop, and the address of the workshop, let me just write down these details here. So we have a workshop coming up, right? Or workshops rather, whichever way. So a workshop is basically you being able to come in person. We're going to be meeting in person, and we're going to go through, you're going to be asking whatever questions you need to ask all day from 8 to like 3:30 over 2 days. The address is 22 Sloan Street, 22 Sloan Street, Bryanston, Santon, 2191, right? And if you're gonna attend in person, that's just 999. That's in person, right? Over the 2 days. And then if you're gonna attend online, it's just 399. This is if you attend online. You see. So let's see what the next question is saying. The next question here is saying 9.3.2 will be concaved down, right? So 9.3.2 will be concaved down. Oh, no, I didn't even answer this question. It says determine the values of x for which f is decreasing. F is decreasing. So this is quite interesting because the thing is, this is what you may call, let's see what it is. What can we do for this question? It is, this is a cubic function, right? And it seems like it's a positive cubic function because you see, f of x is equal to like what? Positive 3x cubed? Yeah, positive 3x cubed minus 3x plus 2. So positive 3x. No, it's just x cubed. X cubed. And then what? X cubed minus 3x plus 2. Minus 3x plus 2, right? So this is because the coefficient of x cubed is a positive number. It means this is going to go up, down, and then up again, you see. So with that being said, we need to keep in mind the following. So it means that this graph is going to be decreasing from one turning point up until the other turning point. Now, what we do know is the first turning point is like -1, right? The other one is like +1. So this is decreasing where x is bigger than -1, but then x is smaller than +1. You see, all this background knowledge, it's stuff you need to know, which is why things like the workshop is important in the online course, because with the workshops, the idea is anyone that does sign up, you automatically get access to the online courses. So that on the day of the event, which is in this case the 18th of October and the 19th. So you obviously are able to attend both days when you make your booking. You attend both days. So that's this part here. Where is this graph decreasing? So if they're asking us where is this graph concaved down, idea is you also need to know what your image would look like. So we know our cubic function would look like this. So in terms of determining where the graph is concave down, what you do need though is the center of the graph, which is the point of inflection, the x value of the point of inflection, you see. So the x value of the point of inflection, you get that from differentiating your equation twice. Let's get the point of inflection first, because once you get your point of inflection, life is a bit easier. Reason is, the side that's smiling, right, that side is concave up. The side that's frowning, that side is concave down. So in our case, we want to find the left side of the point of inflection. So our point of inflection, so if this is, we have to differentiate twice and make our equation equal to 0. So let's see what we're gonna get from our original equation, negative that, and then plus 2, right? Yeah. So let's differentiate this equation twice. So we have to differentiate it once. 3 times that is like 3, and then x squared minus 3, right? That's you differentiating once. Yeah, differentiating again, you're gonna have 3 times 2 is like 6, and then x here. So making this equal to 0, you have divided by 6 divided by 6. This is equal to x. 0 divided by 6 is 0. So, okay, this is quite interesting. So what you now need to know is the graph is concave down where x is below 0. You see, because everything that is below the what you call the 0, that's the part where the graph is concave down. You see, specifically at 0, that's the point of inflection. So here we can say x is smaller than 0. You may be thinking, why not smaller or equal to 0? Well, in this case, I mean, specifically the point of inflection, that's the point where the concavity starts to change. So in this case, we have to say x is smaller than 0. Next question, 9.4, right? 9.4 says, the former question, draw the graph of G. Okay. Oh, okay, this is x minus 3, clearly indicating the intercepts with the x's and the turning points. So this is clearly, all that we can see here is, you want to just be able to see what's going on, and we can. It looks like in the graph of f, all they did was they moved it 3 units to the right. Because g of x here, you can clearly see it's just the equation of f of x moved 3 units to the right. So let's say here moved 3 units right, you see. So if you move it 3 units to the right, let's see what happens. I mean, that's what has happened to the graph of f. So all you do is, you can actually draw the graph of f and then just move everything 3 units to the right, literally, because we have all the information of f of x anyways. So in this equation, let's draw f first, and then we can just move everything 3 units to the right, like literally just do it like that. It'll make your life a bit easier. So with f of x, we know it was a smiling parabola, I mean a positive cubic function. The first thing we know is, okay, we're just going to be doing it as we go. The 2 turning points were at -1 and +1. So if that's moved 3 units to the right, it means instead of being at -1, it's going to be at +2. That's the first one. And then it is also going to be from +1, if it's moved 3 to the right, then it's going to be at, yeah, from 1, 3 to the right, it's going to be at 4. 4 over there. And then what we said is the point of inflection starts off at 0. So from 0, if you move 3 to the right, it's going to be somewhere at 3. This is where the point of inflection is going to be, you know, where the graph starts to change. In terms of x-intercepts, we said it had 2 x-intercepts. The first one was where x was, what was the x-intercept? It's at -2 and 1. So the one that was at -2, if it moves, it's going to be at 1. And then the one that was at what you call, was it -1? Yeah, the one that's at like wait, no, we did the one that was at -1 just now. Okay, where was I now? Oh, yeah. So the first x value, right, was at what? At -2. So obviously -2 and 1. So 1, if you move a 3 to the whoa, yeah. So the negative, if you move a 3 to the right, that's how it became the +1. The 1, if you move a 3 to the right, it becomes this 4 here, which makes sense. So the idea now is this is where you just need to be creative. So the actual turning points, let me see if we got the actual coordinates. Because if we did, oh yeah, we did get the actual coordinates. So this the y value here was 4. The y value here was 0. So those remain the same because if you move it, nothing is really going to change. So somewhere at 4 up here, you have a turning point. Somewhere at 0 here, you have a turning point. So the one that was at 4 is the one that was at -1. So when that was moved, it became +2. So you're going to have your turning point over there. And then the other turning point was at 0 initially as the y value, so it's going to still be there. You see? So all this is one of those things where you may have to watch this video twice. So the first x-intercept, it's going to be at 1, right? So it's going to cut the x-intercept here. The y-intercept is clearly going to be, it started at +2. So if you move your graph to the right, it's going to not be positive. It's still going to be is it? Oh, wow, this is kind of awkward. Because I'm thinking to myself, if you move a graph to the left or to the right, I mean, does that change? This is gonna not be 2, so don't get fooled. But anyways, let's see. This is gonna go down, it's gonna go up. It's gonna be a point of inflection here somewhere, and then it turns there like that, you see. And then it's gonna go somewhere here. So they said intercept with the x's. You see, we need to get the intercepts with the x's. So this is like what we have here. This is like x, and then this is like y. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning, and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. So obviously they say we should get everything, right? So meaning we need the y-intercept here also, of which getting the y-intercept means we need to throw in x as 0. So in this equation, you have to throw in x as 0. So if you throw in x as 0, that's going to be 0 here, 0 there. So it's going to be like -3 cubed, and then 0 there. So it's like -3 here, and then +2. So this is like g0. This is like -27 plus 9 plus 2. So what do we have now? 3 times, what do we have? This is going to be -18 plus 2, which is going to give you -16. Wow, that escalated so fast. But let's see what we get over here. Yeah, wow, this looks so perfect. This is like -16. Here we say this is 2 coordinate 4. Here we say this is 4 coordinate 0. So this one is already fine. These dotted lines were just for them. This was just to guide us, you know. So this was also just to guide us. So we can remove that, we can remove that, we can remove this, we can remove all this and this. So that's that, you see. That's going to give us 4 marks. So this was a nice question. So let's move on to the next one. See, the next one out of 2 here, it says determine the values of k such that g of x is equal to k always has 3 distinct roots. So, well, okay, so the equation of g of x, right? We know it's well, we might as well use our image, because I mean, like, our image was quite expensive. Hey, like, wow, might as well use it because it's gonna help us with this question here. So what we have here, let me see here, make this smaller. So the big idea is the following. If they say determine the values of k for which g of x is equal to k always has 3 distinct roots. So for it to have 3 distinct roots, it all has something to do with your y values of your turning point. So you see, the y value of the turning point here is a 4, and then a 0. So there's a 0 there, there's a 4 there. So what you know is, if your y-intercept is going to have what you call, if your y-intercept, if your graph rather is going to have 3 distinct roots, it needs to be moving between this y value and this y value. You see, so the y value here is a 4, the y value down here is a 0. So if you move it anything below 4, your graph will be having an x-intercept somewhere there, and then another x-intercept, and then another x-intercept. So visually, let me show you what that looks like. So you see the way it is now, right? You see here, the way it is now. You see, if you move it any units, any amount of units downwards, there's 1, 2, and 3. You see, 1, 2, and 3. So one x-intercept, second x-intercept, third x-intercept. That's if you move it anything below the 4. If you keep moving it downwards, eventually you see it's still having 3 x-intercepts until you've moved it a maximum of 4 units. Then it will only have 2 x-intercepts. So for it to still always be having 3 x-intercepts, you can see you can only move it between 0 and 4. So the idea, what you're gonna now do is, you see k here. K is, if you move k to the left, you're gonna have g of x minus k, right, equal to 0. So g of k here moves the graph up or down. This is a vertical shift. You see, it's a vertical shift. So if you're gonna move it up or down, it's k that tells you all that. So because there's a negative here, if you're gonna move it downwards, the k value has to be a plus. So k value being a plus, if you're gonna move it downwards, like let's say if you put, your value of k should not be bigger than 4, because if it's a positive 4 here, you would have had minus 4, which is moving it 4 units maximum downwards. So k should not be bigger than 4. So k has to be below 4. And then your k value also, it has to at least be moved downwards any amount of units. So k cannot be a 0. It has to be at least anything bigger than 0. So k is bigger than 0, you see. So remember, if these questions here are still going a bit over your head, then remember, you need to now find yourself signing up for things like the online courses or the workshops that we have, you know, or the one that's currently going to take place on the 29th of I mean, on the 18th and on the 19th of October at Bryanston. So there's a workshop, meaning you can, it's more like tutoring. And what you can keep in mind is you will be able to have all your questions answered. It's going to be electrifying, you see, because if I can show you an idea of the location or the, well, in terms of where the workshops take place, right, the ones in Bryanston, you have to keep in mind that the idea is that it is in a location where, you know, it's safe, it's secure. You'll be able to go through, we'll be able to go through all that we need to go through, and you're gonna have a good time. So if you see here, right, in this video specifically, this one on the main channel, the one thing that if you say here, you see this is the boardroom where we have the workshops, the ones in Bryanston, and the big idea with this, you can see it's like a huge table where we can collaborate. There is a huge screen there for us to interact with the guys that will be joining in online. There's a huge whiteboard there for us to be able to, you know, just work out sums and everything like that. So this room is air conditioned. You see two aircons over there. Let me see here. Go back, bro. Come on. So that at least it's not like hot or anything. You see. So that don't take any of this for granted, because it's very, very important. You see, there's one over there, and then there's another one. Come on, bro. 10. I want to show people the aircon, man, to show that it's properly air conditioned in this place. Because for in-person workshops, you know, sometimes it's a bit hot or stuffy, but you can see that's not the vibe here. The vibe here is totally different. You see, the vibe here is totally, totally different. You see. So you don't want to miss it. You see, there's another icon over there. So this is like a proper stuff, you know. So you don't want to miss it for anything, you know. So in person it's 999. If you're not joining online, that's just going to be 399. So for now, let's move on to question number 10. Okay, 10.1 says the diagram below shows a rectangle, right? OABC. So there's O, A, B, and C over there, right? And then it says B lies on a straight line, which has this equation. Then it says C lies on the x-axis, yes. And then it says A lies on the y-axis. And then it says here, if B is a coordinate, so B is obviously a point on the straight line. That's all they're trying to say here. They're trying to emphasize the fact that B is a point on the straight line. So they said B, if B is this, right, write down the length of OC and OA in terms of x. So OC, the distance is x, and then OY, the distance is y. However, we know that y is equivalent to this, you see. So write down the length of OC. So OC, it's equal to x, and then OA, it's equal to negative 3x plus 9, you see. Because I mean, like, the x value here is determined by this, the y value here is determined by the y there, of which the y value here, as they have shown us, is determined by negative 3x plus 9. So 10.2, right? 10.2 for 4 marks is determine the coordinates of B for which the rectangle is a maximum. So since we're talking about the area, you need an area formula. So the area formula, remember, it's just length times breadth, right? So here it's going to be x times y. So here it's going to be x multiplied by the y, which is like negative 3x plus 9. So with this being said, right, if you multiply this out, it's like negative 3x squared and then positive 9x. So this is area. So with this being done, or rather with this being said, right, let's differentiate now. So it's like we have the area formula in terms of x. So when you differentiate it, it's going to be negative 9x and then plus 9. So since you want a maximum area, you differentiate and you make your equation equal to 0. So this is like 0, negative 9, x plus 9. The 9 goes over, it becomes a positive. Divide both sides by 9. Yo, what am I dividing by x now? Supposed to divide by 9. X is going to be equal to 1. So with what we have gotten here, right, well, we're obviously not done, because it's like what? We determine the coordinates of B for which the area will be a maximum. If the area is a maximum, x is 1, but this doesn't look right. Yeah, why does it not look right? Because it's like negative. Dude, it's a 6, bruh. Come on. Aye. This is so dumb. 3 times 2 is a 6, bruh. So it's 2 over 3. That's the x value that will produce the maximum area. So that's the x value, right? So we need a y value also, because the coordinate has the x and the y. So for y, we're going to make x equal to 2/3, right? And then minus 9. So 2/3 and then minus plus 9, I mean. So this is like -2 plus 9 is like a 7. So it means the coordinate of b is the following, right? This is the coordinate of b. B is 2/3 and 7. So let's move on. Let's keep moving forward. Let's move on to question number 11. Question number 11, right? It says, during a survey at a certain school, 900 learners were asked to indicate what sport they would like to play as a winter sport code. Then it says the learners could choose at most 3 codes. The sport codes indicated by learners were rugby, hockey, and tennis. There will be boys and girls teams in all 3 sports. The data collected is shown in the Venn diagram. Oh, this is such a interesting question. They've actually given you a lot of information in the Venn diagram. Usually they don't, you know. So anyways, this is to say everyone that plays all 3 sports you don't know. This is to say people that play rugby and tennis, it's 60 plus X. And then these are people that play rugby only and tennis only. This is people that play rugby only, hockey only, tennis only. These are people that play tennis and hockey. These are people that play both tennis and hockey. X plus 85 is everyone that plays tennis and hockey. X plus 55 is everyone that plays both rugby and hockey. Then he says, determine how many learners want to play all 3 sports. Wow, you have to solve for X. Highball. Oh, it's a total of 900 learners. So we have to add up all the numbers, you see, and make them equal to 900. So we know 900 is equal to 160 plus 55 plus 60 plus 255 plus 85 plus 200 plus 45 plus X. So let's see what we are getting here. So everything here in the calculator is giving us 860. Then this is like 900. And then if you move it to the other side, it's going to be 900 minus 860, right? This is equal to 40. There we go. That's the way we like it. Let's move on to the next one. The next one says, if a learner is randomly chosen, what is the probability that he or she prefers hockey only? So people that want hockey only, it's 200 of them, you see. So it's 200 over 900. So this is just going to be 2/9. And then determine the percentage of learners who are likely to play at least 2 of the sports. So people that are likely to play at least 2. At least 2 refers to these people here, and including these ones, and including these ones. These only play 1, these only play 1, these only play 1, these play none. So in the middle here, we know this is 40, right? So we're going to say 40 plus all these numbers divided by 900. You see, so 40, remember there was a 55 there, there was a 255, there was a 85, yes, and then there's a 60 and a 40 plus 60. Yeah, because it's 1, 2, 3, 4. Wait, what? 1, 2, no, 1, 2, 3, 4. Why am I putting the 255 now? Seriously, bro, come on now, wake up, my guy. So it's like these 4 put together, right? These 4 put together, let's see the total. Whatever the total is, we have to put it over 900. So this is like 240, right? So the probability of getting someone that at least plays 1 is going to be like 240 over 900, which is 24 over 90, which is going to give you 12 over 45. Yeah, which is interesting. Percentage wise, you have to times by 100. So let's times this by 100. Let's see what it gives us in the calculator. In the calculator, we're getting 26.7%. Not bad at all. Move on. So 11.2 says, consider the word spectrum. How many ways can 8 letters be arranged in any order? So if it's 8 letters, I mean like spectrum, none of the letters repeat, fortunately. Yeah, so you can just say 8 factorial ways, of which in our calculator, that's giving us 40,320. It says, how many ways can letters be arranged such that the first letter is a vowel? Well, how many vowels do we have? We have 1, 2. So only 2 options for the first position. Yeah, so if there are only 2 options for the first position, you see you have 1, 2, 3, 4, 5, 6, 7, 8, right? So with these 8 things, right, what we know is 8. Yeah, so we have 8, right? So in the first position, how many options do we have? We only have 2. So it's 2 options for the first position. And then once a letter is put here, there's only 7 options left here. 7, and then 6, and then 5, 4, 3, 2, 1. These are the options that we have if the letter is supposed to start with a vowel. So in the calculator, well, technically you can just say 2 times 7 factorial, which is 5,040. But if you times by 2, that's 10,080. Okay, that's 2 marks. That's B. The next one says calculate the probability that in a particular arrangement of the 8 letters, the letters P, T, and R will be next to each other. So if you have 8 letters to choose from, right? 1, 2, 3, 4, 5, 6, 7, 8. If 3 of them are meant to be stuck together, what you do is you imagine 3 being stuck together, right? Like this. You literally paste 3 of them together. So what happens now is you're dealing with 1, 2, 3, 4, 5, 6 objects, right? So that they can be arranged in 6 factorial ways. But then the ones that are stuck together, they can be arranged in 3 factorial ways, you see. So 6 factorial times 3 factorial. But the thing is, now they say they want the probability of that happening. So this is where we have to be careful. So here, these are the arrangements, right? But then the total number of arrangements without any restrictions, it's 8 factorial. So whatever the number of outcomes here, we have to put over 8 factorial, which in this case is giving us 3 over 28. Moving on. The next one says, a bag contains only 2 colors of tennis balls, red and green, in the ratio 1 to 3. 2 balls are picked at random, one after the other without replacement. Calculate the number of balls in the bag, given that the probability of picking first a red ball and second a green ball is 1 over 5. Yo. So these kinds of questions, don't just read them once and you're done. Nope. It says a bag contains colors, right, of tennis balls. So 2 colors. They said we have red and they said we have green. So they said in the ratio 1 to 3. So whatever the red ones are and whatever the green ones are, the ratio is 1 to 3, meaning you have 3 times more green balls than the red ones. Then it says the 2 balls are picked at random, one after the other without replacement. Calculate the number of balls if it is given that the probability of picking red first and then the second one green is this much. So obviously this is red and then green. So when you pick for the second time, you can also just get either red or green. You can also then either just get red or green. So the idea is, firstly, we don't know how many balls we're dealing with, but it doesn't matter. This you have, let's just say, remember, if you're dealing with a ratio of 1 to 3, what you can actually do for yourself is, I mean, like, you can think to yourself, fine. What we do know, right, is we don't have the specific numbers. So if they say the probability that the first one is red and the second one is green, that scenario is here. You see, first one red, next one green. And they said here the probability of this is just 1 over 5. So what we know is, firstly, the total balls that we have, we don't know. So we might as well label it X. That's the total balls we have in total. But the red ones, we don't know what number that is. So we can just say, yo, it's crazy. The thing is, this ratio should help us, because how ratios work is, for every one of these, you have 5. I mean, for every one of these, you have 3 of the others. You see, so that's kind of like something we need to mathematically put on paper, the fact that the ratio is 1 to 3. Because what you know is let's just say the red balls, right? Red plus green is equal to X, right? But then the ratio is 1, 2, 3. So you need to share X using ratio 1 to 3. So if you're going to share X using the ratio 1 to 3, right? What you do is you add the 1 and the 3, get a 4. And then what you do is for the 1, you say 1 over 4 multiplied by X. For the 3, you say 3 over 4 multiplied by X, you see. So what this is saying is everything is X, right? But then the portion that goes for the red is just X. The portion, just 1 over 4X. The portion that goes for the green is just 3 over 4X. So that's how we have divided the green and the red. So the amount of greens, for red it's 1, right? So here we say the amount of red is just 1 over 4 of X. And then the amount of greens, we said it's just 3 over 4 of X, you see, the total is X. So the chances of you choosing red the first time, it's a quarter X over X. And then green, all the greens are still there, but it's gonna be 3 over 4 X. But the thing is, 1 is gone. They say we replace it. Let me just double check here. They said here number of balls without replacement. So without replacement means you take it out and it's gone. So the total here is not X anymore. It's X minus 1, you see. So now that we know that this is our two values, what we know is this number times this number is what gave us 1 over 5. So we can use that for our calculations, you see. So what we now know is a quarter. This is like a quarter divided by 1, right? That's just a quarter. So the x's cancel out. So here we have a quarter multiplied by, remember you multiply the probability. So this probability times by this probability. So we're going to have here 3 over 4x over x minus 1. This is 1 over 5, you see. So yeah, that being said, we need to be careful, you see. So us being careful, we now know that, okay, fine. Let's see, let's get rid of the quarter actually. Divide by a quarter here, divide by a quarter. This is going to give us 5 over, this is going to give us 4 over 5 actually, 4 over 5. And then this here is like 3 over 4x. And then we have here x minus 1. So since we're dealing with a fraction, we might as well cross multiply. See, the denominator times the top is going to be 4 times x minus 1. And the denominator here times the top, it's going to be 5 multiplied by 3 over 4x. So here, if you multiply inside, you're going to have 15 over 4x. Here, you're going to have 4x minus 4. So if you move to the left, you're going to have a 15 over 4x minus 4x equal to 4. No, negative 4, I mean. So all this being done, why did I put the ones with x's to one side when I could have put them to the other side? Let me put them here. Let me put the ones with x's to the other side. So it's going to be 4x here minus 15 over 4x. Then the 4 positive 4 is there. So 4 minus 15 over 4x. Let's see what that gives us in the calculator. Okay, so this is giving us, what is it giving us now? 4, Well, let's just finesse it actually. So times this is going to be 16x minus 15 over 4 with the 4 here. Yeah, because I just multiplied this by 4 over 4. Because the top is going to be 16. And then, yeah, so that now we can just say multiplied by 4 on both sides. This cancels out here. 16 here is equal to 16x minus 15x. This is like x is equal to 16. So yeah, the final answer is 16. And that is where we are ending off this paper. It was 150 marks. Nothing crazy, nothing major. So I'll catch you in the next video. Obviously, depending on everything that we've spoken about, right? This is where you're going to get the more deeper explanations. If you need anything, you can also just hit me up. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description. So as you can see, where I am is at 22 on Sloan. This is where we're going to be hosting our in-person workshop on the 18th of October and on the 19th of October 2022. So the workshop is going to start at 8 in the morning and we're going to be ending off at 3:30 in the afternoon with a break in between. As you can see, the idea behind the workshop is we will be able to work on whatever we need to work on the whiteboard, and for those that will be joining in online, we will be able to interact with you via that huge screen over there. If you don't want to show your face, that's still 100% okay. We will be able to maybe in some instances just read your questions. You'll be able to send through your questions. We'll be able to see you. This is going to be something you definitely do not want to miss. As you can see, the seats here are limited. This table though is huge. It's big. You can already get the vibe. It is going to be electrifying. This is something you definitely do not want to miss. If you would like to sign up, the link for that is in the description. For you to be able to attend in person, that is going to cost you $999. If you would like to join in online via Zoom, that is going to be $399. The link to that is in the description.